In our average case, and there's no best case actually, Big O efficiency is n log n. Whenever you split into the two sets, that means there is log n. But if you do not split into the two sets each time, we call that as a worst case. Worst case Big O efficiency is n squared. It is very similar to the selection sort. Selection sort is find the max and swap to the last. Pivot is finding the position of the current pivot and swap. So when QuickSort looks like selection sort is two conditions. When both conditions are true, it acts like selection sort. First condition is pivot is at the end. That means first index or last index. If pivot starts always from the first one or last one, and at the same time, if the data is sorted or reverse sorted, in that case, we cannot split into half, so it has the worst case. So I'm going to quickly show a little bit about the first one. When it has reverse sorted and I still need to make in order, ascending order, pivot starts from 8. Then first we'll move 7 is smaller than 8, 6 is smaller than 5, 4, 3, 2, 1. It's all smaller than 8. So first we'll point index 8. Then last will stay there. They already crossed. That means swap pivot and last. So index 7 is fixed. At the time, how many times comparison? 1, 2, 3, 4, 5, 6, 7 times comparisons. Then in the second time, pivot starts from 1. Then first stops at index 1. But last, compare with 2, 3, 4, 5, 6, 7, and last will point index 0 finally. Oh, was there 8 comparison? I'm sorry. I think 8 is right. So let's compare, let's count how many comparison happen. First compare 1 time in the second pass. Then last compared 1, 2, 3, 4, 5, 6, and 7 times comparison. So total 8 times comparison again. Then one swap by itself. Last time pivot is pointing the same. Then it is fixed. If you see there's no swap between first and last, that means that there's no quick adjustment. Then the next time pivot is 7. Then first will go to all the way end. Then last will do not move at all because they was the first. So first we'll compare 1, 2, 3, 4, 5 times. Then it's gonna just swap 2 and 7. Next time, another 5 times a comparison. No swap between data in the middle. Just only end. You're gonna swap only itself or to the end. Itself to the end. That's why the gray is on the left side and right side only. Then next time you do compare like 3 times. 1, 2, 3. Then 3 times. Then 2 times. Then I think it's just 1. 1, 2. I think 2 times. Or 1. So if I just add all of the number of comparisons, and 16, 26, 32, 33, all way much bigger than n log n was 24. Then at the array 1, we compared only 16 times. So this number of comparisons is very similar to the selection sort. Compare all the data except the fixed one and swap 1 time at the end. Compare all the current sublist data, swap at the end only 1 time, each time. So that is a selection sort behavior. So in that case, we say worst case, that is Big O square, because there's no splitting part. If we go back to the average case, and also ascending order is the same thing. It swaps by itself all the time after compare all the way. So last will start from 8 and all the way come to the 0, and starts from 8 and all the way come to the 2. Starts, end, starts, end. That is the when the data is already sorted. In that case, every single data, every single pivot is swapped by itself. 1, then 2, then 3, something like this. So that is also worst case, big O n square, because it has the same number of comparison as the descending order has. Almost the same. How about if we have average case as big O n log n, quicksort, and merge sort was also big O n log n. Which one is better? If it's average case, quicksort is better. Quicksort is faster than merge because merge sort it needs another array, the copy buffer. It copies to the copy buffer and copy back to the original array. So it takes a kind of time. So when you have a big data, quicksort is faster than merge sort. In the most cases, in the average case, that's why quicksort name is quick. It's a quick, so quicksort.